Hello again and welcome to ISAC Software Academy Linux course. Today's lesson will be about users and groups in Linux, and as a natural extension of that we will also be discussing the permissions that are in use on Linux file systems. In a Linux and Unix system, the files and folders are all permissions based, and what this means is that for you to use a file in any way, whether it be to read, write or execute it, you have to have the required permissions. This is done also on other systems such as Microsoft Windows, however it is to a much lesser degree. With a Linux and a Unix system, it is done inherently. Everything has a permission, and this is designed to be a security feature. When you see the permissions listed, which you would have done in one of the other videos where I have listed out the contents of a directory using the -l parameter, it will show you the permissions that are inherent to that file or directory, as it may be. These permissions that are split into three categories are split into user, group and everybody, and this is done by using three groups of three, as you also have read, write and execute. These are not all of the options listed when you see a -l parameter on an ls listing, as there is one other, and the first character of these listings can be one of 7 options. It can be a D for a directory, and it can be a dash to indicate a regular file, an L to mean a symbolic link, an S to mean a Unix domain socket, a P to mean a named pipe, a C to mean a character device file, or a B to be a block device file. Generally, you'll only really see the first 3. You will see others from time to time, but it's generally either going to be a regular file, a directory or a symbolic link that you will see, and as such we won't be covering the others. The dash is indicative of it being effectively blank. It means it does not have a value. It's designed to say there is nothing here. As such, when you see these permissions listed out, where the dash means a regular file, it actually means that it is not a special file, as it has no value. The dash in any other section means that there is no value there either. If it does not have a value, that means that it is not permitted. So if it had, as an example, an R, a W and then a dash, this means you could read it, write it, but not execute it because the X is not there to be seen. These permissions can be changed, but do require that you have access to change these permissions. These can be changed using a command that is short for change mode and is spelled CHMOD. It is quite often pronounced as chmod. However, you can simply call it change mode, as it is more intuitive to do so. Using that command you can change the permissions to whatever is required. Most regularly you will probably need to be using it to add an execute permission to a script or some other executable. This will allow you to actually run it, where it would not be able to be run without that execute permission. Something to keep in mind is that the root user is the super user for the system. And as such, anytime you see root as either the user or the group, as there is also a root group, that means that it is the super user that has those permissions, or anybody in the super user group of root. It is very much like administrator account on a Windows based system. To set a password for an account, you can use the passwd command, which is obviously short for password. This can be used not just for the current user but also any other user by specifying that user when you execute the command. The groups command can be used to check the groups that the current user or another user that's specified is in. The group add command is used to make a new group. You can also add a user to a group by using the useradd -g command, but this is done while creating that new user. The ID command checks the ID numbers, and as part of its default configuration will actually check what those numbers relate to for your groups that your user belongs to. The usermod -a -g command can be used to add an existing user to a group. We'll now demonstrate this with a more practical approach. In this directory I have created for testing purposes, you'll see it is presently empty, however that there are, as you can see right here, permissions associated with the dot and dot dot default directories. Now I am going to make a directory called ISAC test, and when we do a listing again, you will see that the user is ISAC and so is the group, and these are the permissions associated with that as a result of ISAC being the user and group. Now if I were to do a sudo makedir and did the sudo test, you'll note that it is now the root group and the root user, and the associated permissions here indicate what can and can't be done with that particular directory. Now these last three indicate the permissions for everyone. Now that's anybody who has an account. As a result, you can read and execute, but you cannot write because the write permission is missing, as you can see by that dash. Now this is also true of anybody in the root group. However, the root user specifically has read, write and execute permissions. The D obviously indicates that it is a directory. Now we can in fact go into the sudo test directory and see that the permissions are in effect the same. If I, however, create another directory inside this directory, or at least attempt to do so, I do not have permission to write to this directory. That said, I can do a sudo and it will actually work, as you can see. But again, this is created using root permissions. Now we will go up again and we will go into the ISAC test directory, which as you can see is empty. We will now create a file by using the touch command, and we will call it for this purpose ISAC file. Now listing it again, you can see that once again the permissions have been set and it is owned by the ISAC account and it is in the ISAC group. Now, as a result of this, we actually have read-write permissions, which obviously you would want being the owner of the file. This is the default behavior. The owner has read-write. Now, we could make this executable. Despite the fact that it is in fact an empty file, we can in fact make it an executable by simply saying chmod and going +x and then specifying isac file. Now, this will give, as you'll soon see, all of them, the everyone group, the groups group, and the user, they have all got execute permissions. This is where you can be a little bit more selective. As an example, you can use numbers. Now, these numbers are a representation of the binary that is used to display each of these permissions. A 7 is all ones, so this means that read, write, and execute will be available. A 5, however, is not all ones and will actually block things out, and I'll show you exactly what it does when we do this now. As you can see, only the user now has write permissions. As a result of this, the only one that can change this is the isac user. Now, we can use this to our advantage in a security sense. However, keep in mind that the root user will still be able to use this file in any way, shape or form that they so choose. The root user obviously has a great deal of power in this instance. So that's a demonstration. Now, you can also do this by removing I believe it's 4.4. We'll actually remove it. It is now read only. Now, the 4 is the bit that is related to reading. If you add the 1 bit to make it a 5, that adds execute. There is a 2 bit, which is why it goes to 7. So as an example, we could in fact do a 766, and when we list this out again, it now has no execute permissions except for the user, but it has read write for everybody. So that's an example of the permissions. Now, we're going to go and have a look at what groups I am a part of by listing them out as the groups command. As you can see, I am in the isac group, the ADM group, CD-ROM, sudo, dip, plugdev, lpadmin, netdev, and samba share groups. It is very common to be in multiple groups, and this is quite often the default. The CD-ROM group is used to be able to actually write CD-ROMs, or sorry, use CD-ROMs in general. So if you want to read a CD-ROM or write a CD-ROM, then you need to be in that group to have permission to be able to do so. Now, I also listed the ID command. As you can see, this lists out all of the same things, except it gives me the ID numbers of these groups, and also my user ID number, which in this instance is 1000, which by default means I am the only, or the first at least, user on this system, other than the root user and various other users that are default installations or part of another installation. You can also find information about the user_add command by putting in a man before it for manual, as we've discussed earlier. This will give you all the information that you could want about the user_add command, including here you'll see that it has mention of groups. Now if you scroll down through, it'll actually give you a description here. You can see there that the groups option is listed, so that's usable during adding of a user. Obviously this is being done through the command line, and there is a way to add users in the graphical interface. However, that's one to keep in mind. And this can be done for almost any command. Some commands aren't listed, however it's a good way to actually learn about these commands. And as an example, I'll show you the chmod command, which here doesn't have a great deal until down here with regard to the options. Now you can do quite a few things. Obviously there's a recursive, so you can actually change things recursively. You don't have to do one at a time as we have done, but generally that's how you will be doing it. The one time this might change is if the permissions have been somehow stuffed up, just been overwritten, or for whatever reason are no longer what they should be, and you need to do it for an entire directory or even an entire directory tree. This can be done using these commands. And that is it for this lesson. I hope it has been helpful, and goodbye.